All right, so what is the game loop? Go ahead.
Like when the game keeps asking questions.
Okay. So over and over again, the game has to keep asking questions, has to keep executing the behaviors of our actors, so that things keep updating on the screen. And what we talked about last time is there's this delicate balance between how often that should happen. It needs to happen often enough to make your games feel like they're real time, yet not so often that everything gets sluggish. Right? If we're asking the questions every millionth of a second, that means 1 million times per second we are determining if Mario is hitting the turtle guy. Okay, probably doesn't need to be that often, but if it only happened once per second, now it's a bigger problem because that allows you to possibly run right through the turtle guy and never actually impact him because you did it within the 1 second period, something like that. Okay. So related to that last time, we talked about this concept of a thread. So thread, if we gave a formal definition to it, is a lightweight construct in an operating system that tricks the user into thinking that more than one thing is happening at once. And this was as opposed to something called a process, which gets its own time on the CPU. One process may own several threads. So the idea is if I'm a process, so I'm the game salad process, and I spawn 20 threads, those 20 threads are sharing my time on the CPU. Okay? They don't each get their own time on the CPU, they're sharing my time on the CPU. So I'm in control as a process how my threads execute. All right, so Game Salad being a standalone application would be a process in and of itself. And when this process is running, it's getting its own time on the CPU. When you take the operating systems class, we talk about the different ways that we do CPU scheduling. How does this program and all these other programs I have running, how do each of those get time on the CPU so that from our perspective, everything's running at once? That's kind of the punchline right now, is when we are using our computers, we expect everything to be running simultaneously, even though we know that it's impossible for everything to be running simultaneously. In our quad core processors today, the most that can happen at once is 4 things. The most that can happen at once. So if you have more than 4 things open, it's guaranteed that you're being tricked. Realistically, even if you have less than 4 things open, you probably are still being tricked, because one of the jobs of the operating system is to try to schedule the different things that are happening on your computer in terms of the resources it has. So if your CPU has 4 cores, 4 math problems, let's say, that it can solve at a time, it has to schedule all these programs you have running your computer, even if there's just 2, in terms of those 4 cores. Okay, well, those programs might not want to do something at the exact same time. Or you might have something on one core that's using a I/O device. So maybe you have one program that's writing to the hard drive, and you have another program that's also writing to the hard drive. Those 2 things can't happen at once, even though you have enough cores to do math simultaneously. You don't have enough, most hard drives have a single read-write head, or the capability of reading and writing something one thing at a time. Well, therefore, even though you have enough cores to do math, you don't have the ability to share the hard drive with more than one resource simultaneously. Does that make sense? Okay, so part of what an operating system does is it shares all the resources on the computer. Now, what a game engine does, and I did introduce that at some point, didn't I? Yep. So a game engine lays on top of our operating system. And what it does is it does game type stuff, physics and math and gravity and all this other crap that belongs in video games. It does it for us behind the scenes. And then it just makes whatever we put onto the screen happen. And that happens separate from the operating system. So as programmers utilizing the game engine, we don't have to deal directly with the CPU. We don't have to say, we want core 1 of the CPU to do this, this, and this. We don't have to decide that we want to spawn off a thread for all of our turtles hopping around on the screen. We don't have to make these decisions. All we are concerned with is the logic of our game. And we have to play within, I think I probably used the Matrix analogy at some point, where Game Salad kind of creates the Matrix from the movie, where we have to play by the rules that Game Salad puts on us. And we're going to run into some situations where Game Salad acts quirky in certain situations. And we have to take that into account to give the behavior that we're looking for to the actors in our game. So sometimes logic goes out the window and it's okay to just trick the user. That makes sense? And we've probably played games before where there's little bugs like that. Things that you know, like there's a certain place you can stand that you just know you're safe. Right? Because you've experienced it enough times. It's probably less common today because our games are designed differently. But it wouldn't surprise me. There probably is safe spots in Super Mario Brothers. Probably a spot where you get right up next to a pipe or something, and you're guaranteed not to get hit by anything in that one place if you just stand there. So, you know, that would be an example of things that weren't really part of the game, but I know there was, I remember some boss fights in some of those older Nintendo games that were like that. You could just stand in one spot and just gun them down, and you knew you were safe. It's kind of stupid. I think Zelda had a boss like that. Any of you play the original Zelda on Nintendo? In an emulator or in the actual Nintendo? You know, that was the only game. The cartridge was actually gold. I mean, it was colored gold. It wasn't made of gold. It'd be an expensive game. Man. They still make Nintendos, don't they? Don't they sell them like as a with an emulator built into it so it looks like a Nintendo? You can plug it in and play the old games and nothing like the original. You had to like blow into the cartridge to get the dust off. Actually, the original Nintendo was the slot loading thing. You pushed it in and pushed it down to get it to lock in. All right. So, in any case, we like using game engines because it allows us to imagine our game and execute the logic of our game without having to worry about all this other stuff. But we still do need to play within the matrix that is our game world. Okay? And part of the rules of that game is this idea of the game loop. All right? Now, just to kind of give an idea of this, we're going to go back and we'll go to Actor 2 since he's currently displaying some stuff. He's displaying something from our top level text to display. So this guy's going to always display text to display. And if we look at these behaviors down here, what the behavior we're currently using is the display text behavior. And well, actually, you can even see it in this list. Notice that behaviors have some color coding next to them. So we have things in blue, or I'm sorry, things in green that are persistent behaviors, and we'll look at that. We have things in red that are actions. We have things in blue that are groups, so these are collections of things. I've never actually used a note, but it must just be something to add comments to our code here. Let's just drag one out real quick. Yeah, just a comment to your code. Did I cover all the different types? Yep, looks like it. All right, so what we're going to do is we see display text. So let's go and look at what kind of guy display text is. Display text is something called a persistent behavior. Okay, so we're going to try to explore and see what that means. At the same time, we're also going to look at something called change attribute. Change attribute is an action. Okay, so let's try to explore and see what that means. So I'm going to drag change attribute out here. And what we're going to do is we're going to say we want to change the game's text to display value. And what is it right now? Is it a number? we're going to change it to a number. Can I actually update the, actually, here, we'll just do this. I'm going to create another attribute of type integer. Looks like we can't actually update the type of a variable, an attribute, after we've created it. So I'll create another one, type integer. We're going to call this guy count. Start it off at 0. Go back to our actors. And again, I made that at the game level. For this example, we could have made it at the actor level, but it won't make a difference. So I'm going to change the game's count variable to be whatever it currently is, plus 1. All right. So the idea is that whenever this change attribute, and here we can actually increment game.count. Okay, that's what this does. Adds 1 to game.count whenever this behavior fires. Okay. Now we advertised last time, and just before I forget, and I want this actor to display instead of text to .display. I want it to display that count variable. So it should start off at 0. We want it to go to 1, then 2, then 3, then 4. See it actually counting. Okay, so as we advertised last time, we have this idea of the game loop, which means something happens so often. So as our game is running, as I've advertised it up to this point, all the behaviors of all our actors get executed. Okay, so given that, what would we expect to experience here? And before you answer that, let's take a guess. How many times do we think the game loop likely runs per second? Again, we're talking about that balancing act. If it happened 1,000,000 times per second, everything's going to get bogged down. If it only happened 1 time per second, Mario can probably run through turtles. How many times do you think something probably needs to happen every second for the game to feel alive?
20 to 30 times a second.
20 or 30 times a second? Fair enough guess. Okay. Realistically, it might be a little more than that, but let's just say that, I mean, it's not an unreasonable guess. Okay. The fact is, I don't know the answer. It may even depend on it's something how Game Salad works. So let's just say it's 20 or 30. Fair enough. So that means every single second, as I've advertised at this point, we would expect this entire list of behaviors to update, which means it's going to display count. Count becomes 1 bigger than it used to be. So initially, count is what? 0. So it should display 0. Then count becomes 0 plus 1, which is 1. Display 1. 1 becomes 2. Display 2. 2 becomes 3. Display 3. So on and so forth. And we should see it update 30 times in 1 second. So this thing's just going to fly, right? Our character's going to just look like he's blinking. So let's go back here, and we'll go ahead and preview it. We'll see that it just says. What happened there? How many times did those behaviors execute? Twice, right? It had to display that 0. Then it incremented to 1, and then it displayed 1 additional time. So something occurred in the setup that caused the behaviors to fire once, and then when it actually displayed on the screen, it seemed like they fired a second time. Okay? I'm interfacing with the screen now. I'm pressing my button. Mario's moving. These behaviors still aren't happening anymore. We should see, this should be certainly up to several hundred at this point, right? Okay, it's not moving. Okay, let's go back. Display text is a persistent behavior. What that means is once you do it, it sets it and leaves it. Okay? And we talked about this a little bit last time with display text because we saw the behavior with some of our variables that changed later, right? Where when something, it would cache that value. It would remember, I think it was maybe one of our actors had the word cat on it, or something like that. and we had 3 cats and a dog, let's say, and then we changed one of them, but it didn't actually change on the actor because that persistent behavior had been cached. What we would have had to do is close GameSolid, reopen it for the memory to be deleted, and then restart the game, and then it would have the new values. Okay? Part of why it's doing that is for performance. If every single time we went to display text, it had to go and resolve this variable, that might become a problem. Right? So resolving a variable means going somewhere in memory, finding that place in memory that's associated with the variable named count associated with the game, looking at what's in that container, pulling out the value, and displaying the value. That takes time. Even as fast as computers are, if that's happening 20 or 30 times per second for every actor on the screen, we can imagine this starts becoming a problem, right? Okay, so what they do is they locally, what's called cache. So this behavior has a local memory value associated with it that holds that value. And it needs to be told explicitly by us, the game designer, to get the new version of that value. All right? Otherwise, it's going to attempt to keep the highest performance game that it can. And we're going to see in this course that you can bog GameSolid down fairly quickly. It's not a, I think I advertised last time, you're probably not writing Battlefield in GameSolid. You're writing more like Angry Birds in GameSolid. So it serves a purpose, but the point is that it's still going to make decisions. When they created the matrix that is GameSolid, they made decisions that would give you the best chance at having a functional game. So instead of having this game loop that you kind of had to play the timing with, they decided that they'd create different types of behaviors, and these behaviors had consequences. A persistent behavior happens and continues to try to happen, as opposed to an action which happens once. But now we have to explore individual persistent behaviors to see how they actually act. Okay, and what I mean by that is we've seen that display text, which is a persistent behavior, and I've advertised that persistent behaviors will continually get called. This guy gets called every single time through the game loop. Okay? But because of the specific behavior, it is written in such a way that it will not update the text on the actor unless there has been a change. And he's become aware of that change. If this was updating, you would expect that we'd be able to see a flicker here, right? Even if the number 1 wasn't changing, even if we were just printing out hello world, assuming this game loop is running 20 or 30 times a second, we should see hello world kind of flickering on the screen for us because it constantly display hello world, display hello world, display hello world, display hello world over and over again. And certainly by the looks of it, it doesn't seem like that's happening. Would we expect, if that is how it worked, that that would be pretty inefficient? If it had to just keep painting on the screen over and over again the same word, as opposed to just, well, I wrote it once, nothing's changed, let's just keep it. Make sense? So displaying text is something that is cacheable. It's doing it, it's made decisions to make it as high performance as possible. If we want this text to update, we have to specify that it updates. Now let's do something here. I'm going to go back into our Mario. Go ahead.
Is there a way to repeat the action?
There is. Okay, you're 6 minutes ahead of me. But good thought. Because remember, we're talking about a way to solve problems, right? Memory, asking questions, and repetition. So we have to have a way of simulating that in our game. So we are, and they're called timers. Okay, but let's go into our actor. Remember last time we were talking about rules. And those rules associated with Mario, that's our way of asking questions, our if statements. This was, it listened for an event, the mouse button event. And when the mouse button was down, we changed the linear velocity on Mario on X to 100. When we released the mouse button, we changed it to 0. Okay? Now, this is a rule, and I'm telling you this rule gets called over and over and over again, just as she pointed out. right? And you suggested maybe it happens 20 or 30 times a second. Okay, I'm promising you stuff is happening 20 or 30 times a second. GameSalad's having to make some decisions on what's happening and how often that happens. That's that matrix that we're living in. So we know when we run this game right now that when I press the mouse button down, I'm holding it. Mario's velocity got set to 100. Now I let go. Got set to 0. Do you suspect while I was holding it down that 20 or 30 times a second it was setting it to 100, setting it to 100, setting it to 100, setting it to 100, setting it to 100? Or do you think it noticed that the value has not changed, so it didn't actually set it? Because as I was holding this, here, let's reset it so I have more interstate to work with here. So when I hold it down and Mario starts going, 20 times every second, it's updating his linear velocity on X to 100. Well, so every 1/20th of a second, we're changing the value to the exact same value it was before. Do you think it's efficient to change that value all 20 times? Or is there probably some sort of checking to see if the value is actually altered? That seems like it'd be more efficient than going to memory, finding the spot, taking whatever's there, overwriting it with 100. That seems like that would be a lot of trouble if it would be equivalent if we had a number on the board and we all got in a line and you had to change the number to 100 over and over and over again. Erase it, 100, erase it, 100, so on and so forth. Be a waste of time, right? Okay, so when I hit this and I'm holding it, the value is going to get set one time. And just to show you real quick, what we're doing here is something called a change attribute. And change attribute in here is an action. Actions happen once and only once, unless we tell them to happen again. Okay? And we can only tell it to happen again inside of certain constructs. Timers are one of them, okay, which we'll talk about. But right now, this is a rule. So as I'm running this, we just set the velocity to 0 or to 100. Now we'll set it to 0. Okay? So each of those change attributes has happened one time. So each of those actions. One of them set it to 100, the other one set it to 0. I'm going to press it again, and assuming it can only happen once, ever, he shouldn't move. But it will move. So we'll see that the event, the mouse click event, does allow us to fire that rule again. Okay? So that rule is a group. And here, just to prove it, we'll see he moves again. Okay? So now we know for a fact that rule fired. The question got asked again. And as a result, it executed that action, that one-time action, another time. That makes sense? And when I let go, it fired the other one-time action a second time. So on and so forth. All right, and if we go and look at our rule behavior, this guy's a group. So a rule is a collection of behaviors, with the caveat that it also allows us to ask a question. Okay, so really a rule has, I guess, 3 collections. It has a collection of Boolean expressions. So right now we have a single Boolean expression up here, actor receives event, mouse button down, but we can add additional expressions to it if we'd like. And we can have these operate, remember we dealt with ands and ors? So this is our way of emulating ands and ors. And all is an and, which means that when all of these Boolean expressions are true, we'll do the true case. Otherwise, we'll do the false case. Make sense? This is our or, the any. Make sense? All right, so, but for right now, we don't have any complex things to deal with, but that's how we deal with ands and ors in GameSalad. Our rules have all or any associated with them. But so we have a collection of Boolean expressions. What's a Boolean expression again? Any expression that boils down to a single value of true or false. So if this is true, we will execute the the collection of instructions associated with a true Boolean expression. So that's what's in here. I can put multiple expressions in here if I want. I'm just randomly dropping crap. Yeah, here, that'll be fun. Now when we press it, Mario's going to start spinning. It's Mario. All right, so we added 2 behaviors now. Okay, so this is a collection of behaviors. That's what this group thing means. It's a group of behaviors. Also, the way we emulate the else is through this otherwise clause. So if this was false, if this was true, do this stuff. If this is false, do this stuff. And this is also a collection. It's also a collection of behaviors. Make sense? All right. Oh, we have an audience. We could have Mario spinning again. Hold on. Let's have him do clockwise. I'm going to make Mario spin, Professor Wall.
What was that?
I'm going to make Mario spin.
All right.
This is our game programming class.
We're just doing a little game program. Do a little tour here.
All right, so here, this is Mario, and this is our first programming class. So you'll be doing this as a freshman. So now Mario spins on the screen, and eventually that guy's going to look like a turtle and probably be shooting fireballs. But right now he just does that.
Copyright laws.
Well, we actually didn't quite cut the character out perfectly, so there is some. So this will be considered a rough draft,
Okay.
not a release. So, all right. So in any case, so now we've had our first presentation. We've presented our beta to a group of people. Okay. So, anyways, this is a group of behaviors. This is a group of behaviors. That's what this idea of having something that's a group, what that means. Okay. Now, back to this understanding how actions and persistent behaviors work. We've already seen that every single time I press the mouse button down, this guy fires. Right? But the question is, I pressed the mouse down once, but I held it down. Is the event associated with me pressing the mouse button down happening over and over and over again, or was it a single event when I first pressed it down? Trying to understand how rules work. Okay, so the idea is as we are, we'll think about, let's just talk about in terms of video games. As we're playing our video games, multiple events occur, right? When we press one of the buttons on the controller, we expect something to happen, correct? Now, some games, you press the A button and it shoots. Sometimes it shoots once, sometimes it shoots over and over and over again. But how many times did you press the A button? Once. When you pressed it and held it, that was a single event. The A button is now pressed. When you let go, that's a single event. I have released the A button. Make sense? Just like in this case, when I press down the mouse button, click on the mouse, that's a single event, a one-time event. Even if I hold it for 20 minutes, that event occurred once. And on that one event, I actually executed this single action. Not over and over and over and over again. Now, given that, does that mean that this rule was not checked 20 times a second? It's an interesting question. We know that we didn't change this or change this 20 times a second, but did we ask if this actor received the event mouse button down? Did we ask that 20 times per second? Seemingly, at the very least, we can't say no. We don't have enough evidence. We know that these things didn't change because, as we just explained, this event occurs only once. We first press it down or when we let go of it. That's 2 separate events, not one event 20 times a second for as long as we keep it clicked down. Okay? Let me add another rule in here. Create a rule. We're going to say actor receives the event, overlap or collides with actor of type actor 2, which is our pink guy. This is actor 1, this is actor 2. So we could name this guy Mario. What was this guy? This is Flame Turtle. All right, so go back into Mario. Now, notice it updated in here. When this rule, so we're going to ask, did Mario collide with a monster? That's the question we're asking. So when this actor, this being Mario, this particular instance of Mario, overlaps or collides with an actor of type Flame Turtle, so anything that is a Flame Turtle, then what are we going to do? Let's see, we should do something, well, for right now, let's just destroy him. Okay, that'll just make him leave the scene. All right, so now, right now we expect that these questions are being asked 20 times a second, right? Over and over and over and over again. Is Mario colliding with the turtle? 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 That seems like a lot of questions to be asking over and over again. So we'll start Mario moving. As soon as he hits, he's gone. He's toast. Okay? We want to think about this as the implementers of Game Salad. Is it more likely that we ask the question 20 times per second? Or did we make each actor aware of certain events? So instead, what would happen is when I click down, we're not asking that question over and over again, but instead, as soon as Mario, well, right, like, so I just put the down button. When I hit the mouse button down, Mario was notified that the mouse button is pressed down, as opposed to Mario asking, is the mouse button pressed down? When we added this rule, we're saying Mario is interested in events associated with the mouse button, specifically the event dealing with the mouse button going down. Okay? Let's throw a second Mario out here. And now both Marios move from a single mouse button. So what happened there, when this scene started and all these actors came into existence, a first pass was made through their rules to look at what events they're interested in. And we saw that with Mario, there was 2 passes through the actually it was with our with the pink box. There's 2 passes through its behavior list when the thing first starts. Pass number 1 is what events are you interested in, among some other things. Pass number 2 is let's execute everything once. Okay, that's why this guy became a 1. But now what's happened is all of these actors, the Marios, have registered themselves with the event listener associated with Game Salad. Okay? So there's this global event listener that just listens for events that occur. And whenever he hears an event, he notifies the interested actors about that event. Okay? So we have one guy that's asking all these questions. Has the mouse button been pressed? Has the mouse button been pressed? Has the mouse button been pressed? Has this dude bumped into this dude? Has over and over and over again. Okay, kind of a global entity, God, if you will, in the game. And when that guy bumps in, the game makes this dude aware that a collision has occurred specifically between you and an actor of type turtle, flaming turtle, whatever. Okay? So somebody's having to ask that question 20 times a second, as our example goes. But is that happening at the actor level, or is it happening at the global level? Okay, well, if it's happening at the actor level and we have 5,000 actors in our scene, that means we have 5,000 sets of behaviors that are each happening 20 times a second. Could become problematic, right? If we can instead have a single thread in charge of all the stuff that's happening simultaneously and have that guy in charge of letting all the other things know, at least for some of the behaviors, that seems like it'd be more efficient. Okay? So at least for right now, we're going to say that's how this portion of Game Salad works. Now, to show you this, what I'm going to do is right now in our flame turtle, we have this change attribute count equals count plus 1. I'm going to actually take it out of here. In a Mac, you hit Command X. I'm going to cut it. Command X in a PC, you'd hit Control X. So I'll cut it. That way it's pasted. So I don't have to spend the 2 seconds creating it again. And I'm going to go over to Mario. And what I'm going to do is whenever we hit the mouse button down, we're going to tell Mario to start cooking, but we're also going to increment the game count every single time that event occurs. Make sense? Okay, so now I've associated this action that was only happening once before. That is, it was just sitting out here in the middle, sitting out here like this, not inside of any sort of event, just sitting here. And we saw that it only happened once. But now I've wrapped it into a group, and we've seen that this group fires every single time this event occurs. So every single time we press the mouse button down, we'll start Mario moving, we'll update this count. Count starts off at 0. Now it's 2. Why is it 2? Love that answer. 2 Marios. 2 different guys responded to that event. Both of them incremented the value by 1. Now there's only 1 Mario. Now there's no Marios. Nobody in the scene is interested in the mouse button down event now. That's why the number's not going up. Does that make sense? So we can force an action to occur if it's wrapped inside of a group that responds to an event. We force it to occur when that event fires. Well, each time the event fires. All right, so here let's do something a little bit fun. So here's Mario collides with a monster. Right now we're destroying Mario. But we'll also spawn a brand new Mario. And the new Mario is going to spawn. You can choose, you can decide what kind of actor we're going to spawn. We're going to spawn another Mario. We could say in front of the actor, behind the actor. Doesn't matter in this case because we're going to have him spawn direction to the left at position negative, is it, I want to say negative 300. Relative to the actor. So direction is to the left relative to the actor. Position is to negative 300 relative to the actor. I'm hoping, if I put the numbers in right, when Mario hits this, we're going to have new Mario show up. And actually the reason they were rotated is because I think that should stay at 0. There we go. Now we can just hold down the button and we have an infinite stream of Marios. Like, hey, it's Mario. I want you to notice something here. That count is going up. I haven't let go of the mouse button. I've held it. So we've already decided that only 1 mouse event has occurred, right? Yet that number keeps going up. What rule makes that number go up? Go ahead.
The collision rule? Every time it collides.
Every time it collides, what's supposed to happen? Mario is destroyed, and another Mario spawns. We're not changing the value of that variable. Where does the value of that variable change? Inside of the was a button press down event, right? But we're seeing it change. Go ahead.
The new Mario has to register that it was pushed down. So it can go up.
Okay, so we just got a brand new Mario on here. And when the brand new Mario originally runs through its rules, it has to, because they're still moving, right?
Mm-hmm.
You know, if this isn't how it worked, those Marios would be static. They would just be standing there. They spawn over there on the side. It looks like I almost got the spawn place perfect. They're spawning a little bit off the screen, which is good for what we're trying to do, but possibly bad if they would just stand still because we wouldn't even know they exist. But in any case, if this isn't how it worked, they would spawn but not be moving because they wouldn't be aware of the mouse down event. That makes sense? These guys were just born. They came into existence well after I pressed the mouse button down. Yet they're aware of it. What does that mean? What does that tell us about how the mouse button down event must work? Go ahead.
Is it cached?
Okay. I'm going to say yes. Who caches it? Does every Mario know about it? Or do we, earlier we talked about this kind of this global thing that's an observer. A lot of game engines, they call it the observer. Okay, so we have this observer that is observing this current scene. And this guy's aware of all the events that have occurred. And when the mouse button is pressed down, that event a switch gets flipped on. So in effect, he's cached that the event has occurred. All right? The Marios are then checking with that. But are they checking with it every second? Every 20 times a second? No, we've seen that's not the case. But when these new Marios were born, one time through, they do a quick check to make sure that they're doing what they're supposed to be doing. Does that make sense? When they register themselves with that event and they notice that, oh, this event is on, they start doing the stuff associated with that event. That's why these Marios are still cooking. Make sense? It's trying to create a race condition there where one Mario spawned and was aware that it was moving, and we'd see him still move while the other one was gone. So we could, but I can't do something 20 or 30 times a second. I'm not that fast. Okay, that kind of makes sense how that's working. So we're forcing that action to occur multiple times. All right, let's see here. Let's go ahead and take out the increment game count thing here. And let's go back into, so now we're back to the, if Mario bumps into the guy, he disappears and then spawns again, but the counter doesn't increase. So if I run this right now, this guy will just be perpetually 0. Nothing's changing with that global variable. It's just 0 forever. Okay? So we're going to go into our actor 2, our flame turtle, and we're going to add a behavior here of type timer. Now a timer, we can say, should happen every so many seconds, after so many seconds, or for so many seconds. We'll play with this a lot, but let's just start with every. So I'm going to say every 1 second, I want to increment the game count. All right, so this timer, when we first start this actor, this timer fires. All right, and what it does is it creates a recurring event. A timer is a group. Okay, here's our timer. It's a group of behaviors. So this says every 1 second we're incrementing, we're doing this action. Actions happen once. This particular action happens once every second. This is our ability to do repetition. So timers are how we do repetition in GameSalad. Timers are how we do repetition. That would make an excellent quiz question at some point. So we'll go ahead and start our game, and we see that every 1 second, that count is changing. So every 1 second, that timer updates. And what's happening to our display text? It's updating as well. But didn't we already decide that that display text only fires when there's a change? Otherwise, we'd see a flicker, right? So what we'll have to explore next time is how is that display text working? I think we're going to find it works very, very similar to how our new Mario actors worked, where it checks in to see, do I need to do something different? When it's displaying a literal, a hard-coded value, nothing will ever change. But when it's displaying a variable, it needs to become aware when a variable has modified. Okay? See everybody on Wednesday.